So welcome to the video. My name is Pushpinder Gill. Let's go ahead and get started with the concept of probability. Now this is a concept video. We'll be doing a lot of questions in the practice videos of probability. So let's go ahead and get started. Let me just get my pen. So what exactly is probability? Let's understand that first. Probability, let's suppose I have these 4 balls in a bag, right? There are 2 blue balls and 2 red balls. So if let's suppose I pick up a ball, what are the chances that it is going to be a red ball, right? So most of you say, all right, since half of the balls are red balls, so that means there are 50% chances that the ball would be a red ball if I pick up a ball. So how did you come up with that 50% answer? I know 90% of you saying, all right, the answer is 50%, but we need to analyze why did you come up with 50%. See, you said half of the balls are red balls, right? So once you said half of the balls are red balls, that means there is a 50% chance that I'll end up with a red ball if I pick up a ball from the back. So how did this half come? This half came if I divide the number of red balls by total number of balls, right? So this is how the probability is calculated. It's the total number of your favorable cases divided by the actual total number of cases. So probability is defined as ways in favor divided by total number of ways. Now this is a very simple and traditional method of calculating probability. Probability is always also said as chances and all those things. It can either be taken in terms of fractions or it can be taken in terms of percentages. So you just multiply 100 over here and you get your probability in terms of percentage. You remember saying that, all right, there are only 20% chances of this happening. That means out of total 100 cases, 20 cases are such in which this thing is going to happen, right? So this is what probability is. So I hope everyone understood the basic meaning of probability. Let's move ahead and see, understand the probability thing. So probability is ways in favor divided by total number of ways, right? Now since total number of ways are always going to be greater than the ways in favor, that means this fraction over here is always going to be between 0 and 1, right? Because this total number of ways are always going to be greater than ways in favor, right? So that means the probability is always between 0 and 1. So in case of percentages, it's always between 0 and 100, right? So I hope everyone understood what probability is. Now let's just solve the simplest of the questions and understand the concept of probability even better. So a number is selected at random from the set. What is the probability that it is even? So what is the formula tells us that what is probability? Probability is the number of favorable cases divided by total number of cases. So let's see what are the total number of cases here. Now I have to select a number from this set. So how many numbers can I select? I can select either this, like this. Likewise, I can select any of these numbers. So if you count 1, 2, 3, 4, 5, 6, 7, 8, there are a total of 8 numbers to select from. And now what do I need? I need an even number. Now it's my turn to see what are the total number of favorable cases that I have. So I have to see my favorable cases. The number has to be an even number. So 2 is an even number, 4 is an even number. Similarly, 24 is an even number. So likewise, my number of favorable cases count up to 2, 4, 24, that is 3. So number of favorable cases is 3. So that means my probability of selecting an even number out of this, it's 3 by 8. Similarly, if I had to select an odd number out of these sets, then it would be easier. The total number of cases are 8, and if you count 1, 2, 3, 4, 5, 5 numbers are odd. That means The probability of selecting an odd number from this set is 5 by 8. So I hope everyone is understanding here, right? It's a very simple question just to explain you what probability really is. Now let us understand a few terms over here, right? So what probability, impossible event. So what you understand by impossible event, we usually say, okay, which is not possible, which cannot happen, right? So since you see over here, probability is a number which is from 0 to 1. It lies between 0 and 1 only, right? So the event that is impossible has probability equal to 0. So if the probability of event happening is 0, that means it is not going to happen, right? Definitely not going to happen. There are no chances that that event is going to happen. Let's say, for example, I throw a dice. Let's suppose I throw a dice and I get the number to be a 3-digit number, right? I throw a normal dice and I get a number to be the 3-digit number on the dice, which is not possible, guys, because a dice has only 6 numbers. So you understand what is an impossible event is, right? The probability of an impossible event is always 0. So now let's see the other part of the story, that is a certain event. Now, as again I told you that the probability of an event lies between 0 and 1, right? So a certain event is an event that is definitely going to happen. Let's suppose death, right? Death is an inevitable truth. That is going to happen. So the probability of an event that is certain is equal to 1. Right? So probability of an event that is certain is equal to 1. That definitely this is going to happen, right? For example, let me just take the same example. I throw a dice and I can get either of the numbers 1, 2, 3, 4, 5, 6. I can get any of the numbers. So probability of that thing happening is it's certain, right? It's 1. So we have done the impossible event and we have done the certain event, which is called the definite event as well, right? Now let's move forward. So the next event is the equally likely events. So equally likely events are the events which has the same probability. Let's suppose there is event A and there is event B. Right? The probability of event A happening is equal to the probability of event B happening, right? Then they are supposed to be equally likely events. Let's suppose, for example, if I throw a dice, let me just go again with the same example. There is 1 can happen, 2 can come, 3 can come, 4 can come, and 5 can come, and 6 can come, and the probability of each of the event is the same, right? Any number can come, right? So that means they are equally likely events, right? So that means equally likely events are the events which has the same probability. Similarly, now let's see the mutually exclusive events. Now, as the name suggests, these are the events which cannot happen together. These are the events which cannot happen together. For example, let's suppose the probability of heads and tails coming in a coin in one throw. So that means these both of events cannot happen together. You're understanding my point? So mutually exclusive events are the probability of those happening together, means probability of happening event A and B together is equal to 0, right? So mutually exclusive events are those events which are totally exclusive of each other and probability of their happening together is equal to 0. Now comes the independent events. Now this is a tricky situation here. Now independent events are the events which has no connection between them. Let's suppose there is event A and there is event B, right? Let's suppose event A, me having a cup of coffee, fine. Event A is me having a cup of coffee and event B is you watching this video, right? So these two events are independent of each other. That means me having a cup of coffee is not depend on you watching the video, right? So these both the cases are independent of each other, right? Now, one are independent events, then there are dependent events. Now, what are dependent events? The dependent events are which totally depend upon each other, right? I'm sorry. Dependent events are which depend upon each other. Let's suppose there is event A and event B. The event A is me teaching you the concept, and event B is your learning, right? So I can say that event B is dependent on event A. Why? Because without my teaching, you will not be able to learn the concept, right? So that means event B is dependent upon event A. I'm just taking a hypothetical example here, right? So I hope you understood what are independent events and what are dependent events. So in case of independent events, the probability that both the events will happen, that means A will happen and B will happen, is equal to the product of the probability of both the events happening individually, right? So probability of both the events happening, that is probability of A intersection B, which pretty much shows that both the events are happening together, is equal to probability of event A happening into probability of event B happening, right? So I hope everyone understood what are independent events and what are mutually exclusive events. Now let's move further and let's just do a question over here. The probability that two persons A and B can solve a problem independently is 0.4 and 0.6. So what is the probability that both A and B can solve the problem? So you can see from this question that probability that event A is going to happen is equal to 0.4, and the probability that event B is going to happen is equal to 0.6. Now I have to calculate that both the events should happen together. That is nothing but probability of A intersection B, which is equal to probability of event A happening into probability of event B happening. I'm sorry for this, guys. So that is equal to 0.4 into 0.6, which is nothing but 0.24, right? So that means there is 24% chances that both would be able to solve the problem. I hope everyone is understanding. We'll go into depth into this concept a bit later, right? So let's just move forward. So probability of an event not happening, right? So let's suppose, let me say this circle here, it denotes the probability that event A happens, right? And this square over here is the complete universe. Fine. So this is the universe, and this circle represents that the probability that event A will happen. Let's suppose you drinking a cup of coffee, right? So let's suppose the probability of you drinking a cup of coffee is equal to P of A. Now what is the probability that you will not drink a cup of coffee? Right? Now, as I've told you earlier, the maximum probability is always equal to 1, right? That means this event is definitely going to happen. So if I say that probability of you drinking a cup of coffee or the probability of you not drinking a cup of coffee, so that event is certainly going to happen. Either you will drink coffee or you're not going to drink coffee. So that means if I combine both of them, you drinking a cup of coffee and you not drinking a cup of coffee, let me denote it by that. So this event here is a certain event, and the sum of this event is equal to 1. So I can say that the probability of you not drinking a cup of coffee is 1 minus the probability of you drinking a cup of coffee, right? So I hope you're understanding here. The probability of me having let's say a samosa, it's x, that, and probability of me not having a samosa, these are certain events. Either I'll have the samosa, either I will not have the samosa, either I'll sleep, either I'll not sleep. So these are the certain events and they add up to 1. So I can say that probability of an event not happening is equal to 1 minus the probability of that event happening, right? I hope everyone is understanding over here. So let's move forward. Fine. Now let us combine two events. So these are the now we are moving towards the question side. These are how the questions are made. Now there are two events, right? I don't know whether they are independent of each other or whether they are dependent upon each other, right? So what happens is, now let's suppose this is an event A and this is an event B, right? So this over here is an event A. Let's suppose this is an event of me attending the college, right? Me attending the college. Fine. This is the event of me attending the college, and let's suppose this is the event of me getting a job. Fine. So this circle over here represents that I am going to attend a college, and this represents that I am going to get a job, right? Let me make the universe as well. Let's suppose this is the complete universe, which pretty much, you know, has everything. So this area, if you see this area which I've shaded, represents of me only attending the college, not getting a job, but only attending the college. This area over here anyhow represents me getting a job but not attending the college, and this area represents me attending a college and as well as getting a job. So I have pretty much explained you all the possibilities that can happen, right? So let's suppose if I want to calculate that either I will attend the college or I should get a job. So what is the probability of that happening, right? So either I attend a college or I get a job. Pretty much anything can happen. So I am looking for this complete area over here. So let me do one thing. Let me add the P of A and the P of B. Right? I hope everyone is understanding what I'm trying to do here. I want to calculate the probability of an event of either of the event happening. I should either attend the college or I should either get a job. Both can happen, even anything can happen. So I have added probability of me attending the college and probability of me getting a job. Now most of you will be saying, okay, all right, you've done the job. But if you look carefully over here, let me denote this area, the both area. Let me denote it by E. Now if you see, I've added this complete area. That means I've added E here, right? Similarly, I've added this complete area as well. That means I've added E as well. That means I've added E twice. That means this area has been added twice. And for me to calculate the quantity of this complete area fairly, I would need to subtract E once, so that in a net effect I have calculated the complete area only once. So for that I have to subtract the probability of both the event happening, right? I hope everyone understood this. I'm sorry for this mess, guys. So probability of either of the event happening is equal to probability of one event happening plus the second event happening minus both of the events happening. So I hope everyone understood this over here. If you're not able to understand this Venn diagram, I suggest you to go watch my set theory video where I'll be explaining this in a lot more detail, right? So this pretty much explains all the concepts of two events when the probability of either of them can happen, right? So let's move forward. Now, what if the events are mutually exclusive? So what do you mean by mutually exclusive events? As discussed in these videos, the mutually exclusive events are those events which cannot happen together. So that means for those events, this thing is nothing but 0, right? So I can say that the probability of two mutually exclusive events happening, the probability of either of them happening is equal to just the sum of probability of A happening and probability of B happening, right? Which is nothing but this, because probability of both the events happening is 0. So whenever I get a question wherein two events are mutually exclusive, I need to assume the probability of both the event happening is 0, and I straight away can use this formula. So I hope everyone understood this. Now let's move forward. Now it's again the same thing, right? What is the probability that either one of them, at least one of them event is going to happen, right? So I have to calculate the probability of at least one of the events. So how do I go about and calculate that? Now I'm going to give you two tools to calculate this event here. So now let's see what those two tools are. Now I need to calculate the probability of either of the event happening. That means I need to calculate that either A can happen or B can happen, right? So I explained earlier, you can easily calculate, okay, A or B, that means I add A, I add the probability of B, and I deduct the probability of both the events happening, right? I can do that. Fine. Or if you want to calculate at least one, right? So if you look at the sample space over here, guys, you need at least one of the events happening, right? So you can say that either A happens and B does not happen. This is one scenario. Or A cannot happen and B can happen. Or there is one last scenario that both of them together can happen. So I hope you're understanding over here what I'm trying to do. I've just listed down all the events, right? So you say, okay, this is one event happening here. A is happening, B is not happening, right? So you know the probability of B happening. From that, you can calculate the probability of B not happening. Similarly, A not happening, B happening. Similarly, both of them happening. Add all of them, you're gonna get answer equal to this, right? So this is one way of doing that. Now let me tell you one smart way of calculating at least one. So what does at least one means? At least one means this whole area, right? This whole area is at least one. And this is one complete universe. What if I calculate the probability of either of the event not happening, that both of them do not happen? So that will give me this complete universe, right? And if I subtract one from them, right, so that means either at least one of them happens or both of them don't happen. This is the scenario here. So I can calculate it by 1 minus probability of event A not happening and probability of event B not happening. So this is even a smarter way to do that, right? I'm sorry for that. So I hope everyone understood this over here, that let me just take a quick recap here. Now we had to find the probability of at least one of the event happening. So I calculated with this simple method here. Probability of A or B is equal to probability of A happening plus B happening minus the intersection of 2, or I listed down all the possible cases which could happen, or I opted for the smarter way. I listed out the way which is the way which is not according to what I want the answer, and then I subtract 1 from that and I can get the answer, right? So let's go ahead and move forward. Now I have to find the probability of exactly one event happening, that A happens and B does not happen, or B happens and A does not happen. This is what I want, and this is your answer, guys. I've told you the answer. The answer is exactly one event should happen. If A happens, B should not happen, right? And if B happens, A should not happen. End of story. This is your probability that exactly one of the event happens, right? So this is your answer. So you just calculate the probability of A happening multiplied with the probability of B not happening plus whatever is there ahead, right? So I hope everyone is understanding how simple it is becoming right now, right? You just understand the question and answer is there in front of you. Now, probability of event both happening. This we have done a lot of times. The probability that both the events will happen, I'm going to leave you to that. That is probability of A, sorry for the handwriting, guys, into probability of B, right? So this is nothing but probability of both the events happening, right? So let's just do some questions now, right? So that we have learned a lot of theory. I'll just give you a couple of 3-4 questions here. We'll be doing a lot more question in the practice video. The probability that shooter A can hit a target is 0.8. The probability that B can hit a target is this. What is the probability that at least one of them can hit the target? Now, if you go back, if you just rewind the video, I told you a smarter way of calculating. I told you 3 ways of calculating at least one. The first way is the probability that event A happens plus probability that event B happens, right? So probability of A happening and probability of B happening minus the probability of both the events happening, right? So this is nothing but 1.8 plus 0.6, that is 1.4 minus 0. It's 8 6 48, that is 0.48, right? So if I calculate that, this is nothing but 0.92, right? So I got my answer here, right? The second way which I did was that I just recommend you to rewind the video back where I explained at least one, so that you don't get disturbed by this. So probability of event A happening into probability of B not happening. So probability of B happening is 0.6, so probability of B not happening is 0.4, that is 1 minus 0.6, plus probability of B happening into probability of A not happening, that is 0.2, right? Plus the probability of both the events happening. So which is nothing but the answer again gives me 0.92. Now let's go for the smarter way, guys. The smarter way was 1 minus probability of both the events not happening. So if this happening is 0.8, so probability of not happening is 0.2. Similarly, the probability of not happening here is 0.4, and if I subtract 1 minus 0.08, I get my answer to be 0.92. So isn't our method consistent overall? So I know this is the smarter way. You'll be saying, why not learn this? But I want you to give you all the tools, right? So sometimes this will help you, sometimes this will help you. Every time all of them can help you, but sometimes this any of them can be more easy to apply, right? So let's just move forward. I hope everyone understood this question, Right. So now we're going to do a simple concept, that is odds in favor and odds against the favor, which is pretty much easy, right? So the odds in favor of an event happening is a ratio of probability of that event happening by probability of event not happening. So the odds against the favor is probability of not happening by probability of happening. So I know if you want the favor, this is how I remember it. The odds with the favor, odds in favor, the probability of happening is at the top, and odds against the favor, the probability of not happening is at the top. The rest, each and everything is same, right? So let's move forward. I hope it's understandable. Now let's just do some questions here, right? So that you understand the concept within the video only. So in this question, among a group of 2,500 people, 35% invest in municipal bonds, 18% invest in oil stocks, and 7% invest in both. So if one person is to be selected randomly from these people, what is the probability that the one who invests in municipal bonds but not in oil stocks? Now if you see, the question over here is in terms of probability. So we do not need this 2,500 people. We can easily go with the percentages, because probability is a fraction. It's not an exact number. So with the percentages as well, you can easily calculate it. Now it says, now how many people are there? If it's a percentage, so there are a total of 100 people. And if I draw the diagram, 35% of the people invest in municipal bonds and 18% of the people invest in oil stocks and 7% is the both, right? Now he's asking, what is the probability that the person selected will be the one who invests in municipal bonds but not oil stocks, which is nothing but this area, municipal bonds but not oil stock. If this whole area is 35, right, let me just make it bigger. If this whole area is 35, right, and this area is 7, that means this area will be 28, right? So 28% of the people invest in municipal bonds but not in oil stocks. That means the probability is 28 by 100, which is nothing but 0.28. You can either say 28% or you can say 0.28 is the probability. So I hope everyone is understanding this question. It looks like a big question, but if you see closely, it's not as big as. And the question confuses you once you bring this 2,500 people into picture. So once you see, the question is asking you fractions. Percentages are given in the question. Go with the percentage. Do not start calculating the figures, right? So let's move forward. Okay, so the raffle tickets consecutively, numbered consecutively from 101 through 350 in a box. What is the probability that the ticket selected at random will have a number with 100 digits of 2? So what is the formula for probability, guys? Probability of an event happening is defined by cases in favor by total cases. So what are the total cases here? How many numbers do I have to choose from? I have to choose from any number from 101 till 350, which is pretty much 250 numbers, right? So it's 250 numbers. All right, and I have to choose numbers which have hundreds digit as 2. Now which are the numbers which has hundreds digit as 2? It starts from 200 and it ends at 299, right? Apart from that, all of the numbers have different digits, and these are the only numbers which have 100 digits from 2. And if you count all these numbers, these are 100 numbers, right? So now you'll be saying, why 99? Now let me tell you guys, 200 is also included. You're understanding my point? It's not that I'm starting my counting from 201. I'm starting my counting from 200. Tell me how many digits are there from 0 to 5. It's not 5. If you calculate, it's 0, 1, 2, 3, 4 and 5, which is 6 numbers. right? Because 0 is also counted. Over here, 0 is also counted. That means there are 100 numbers. So the probability is 100 by 250, right? So I hope everyone understood. It was an easy question just to explain you what probability is. We'll be doing the complex questions in the practice video, right? So I hope everyone understood this. Okay, let's see this question as well. 60% of the members of a study group are women, and 45% of those members are lawyers. And if one member is selected, what is the probability that it will be a woman lawyer? So since it's a percent, let me assume that there are 100 people. Now this is what I call, guys, my tree approach. This pretty much helps you a lot, and especially in GRE GMAT. This tree approach is going to give you a lot of benefit. Now let's see how to do this tree approach. Pretty much simple. So I assumed 100 people and 60% are women. So that means if I draw a branch, 60 are women, and I can say that 40 are men, right? Fine. Now 45% of those women are lawyers. That means 45% of these women are lawyers. So 45% of this 60, guys, is not this 100. So I hope everyone is understanding why I chose 45% of 60 rather than 100, because it's saying 45% of the women, right? So if I calculate it, it comes out to be 27 women. They are lawyers, right? So now he is asking, what is the probability that the member selected is a woman lawyer? So I have women here and I have lawyers here which are women, which are equal to 27. So that means out of 100 people, if I select one person, there are 27 chances that that person is going to be a woman lawyer. Hence the probability is 0.27, or it can say 27% as well, right? So I hope everyone understood this question here. It was pretty simple question, right? So I hope everyone understood the concept that I'm trying to explain here, not the question. So let's move forward. Okay, so if a coin is tossed 3 times, what is the probability on at least one of the coins will turn up tails? Now guys, I told you, if someone asks you at least one, you just say 1 minus of that event not happening. So how many cases are there that even at least one of them will not have tails? That means all of them are going to have heads, right? That means all of them are going to have heads. Okay, all right. So let me just list those cases for you. So I'm tossing 3 coins here, right? So I'm going to toss 3 coins. So the only case in which at least one tails does not come is I get 3 heads. Apart from that, each case is going to have at least 1 tail. So that means I have found one case which does not apply to that condition, and I subtract 1 from that, I can get all the probability of getting at least one of the tails. So what is the probability of getting 3 heads? So probability of getting 1 head is 1 by 2, because out of 2 head and tails, head can come. Similarly, probability of getting the second head is 1 by 2, and the probability of getting third head is 1 by 2, which is nothing but equal to 1 by 8. So the probability that at least one tail comes is nothing but 7 by 8. So I hope everyone understood this question. It's very critical, because if you start jotting out the cases for at least one of the tails, is going to take you a little bit time, right? So this is much smarter way, and we're going to do the coin thing in detail in some further videos, right? So let's just go ahead and do the next question. All right, so the probability that A, B, and C can hit a target is it's 1 by 3 and 1 by 4 and 1 by 5 respectively. If the result of one person does not affect the other, so we have to find these 4 questions. So I would recommend you to go ahead and pause this video right now and solve all the questions, and later on you can match them with what I do, right? So let's go ahead and pause it. All right, fine. So let's see how did you fare. So what is the probability that none of them hits the target? So that means this should be the multiplication of probability that A does not hits the target, B does not hits the target, and C does not hits the target. Which is, if A hits the target, the probability is 1 by 3. The probability of A not hitting the target is this, B not hitting the target is this, and C not hitting the target is this. So if you see this and this gets cancelled, and the probability that none of them hits the target is this, right? Now we have to find the probability that all of them hits the target, that A also hits the target, B also hits the target, and C also hits the target, which is nothing but the multiplication of all the probability, which is 1 by 3 into 1 by 4 into 1 by 5, which is equal to 1 by 60, right? I hope everyone understood. Now we have to find the probability that exactly one of them hits the target. Now this is a little bit tricky case. So there are 3 cases in that. The probability that A hits the target and B doesn't and C doesn't, plus another case that A does not hit the target but B does and C doesn't. So this is one case, plus A doesn't hit, B doesn't hit, but C hits. So these are the 3 cases. Now you understand, guys, whenever a case differs, we have to add, and within that particular case we have to multiply, right? So these are the all 3 cases. You find the probability and you're going to get the answer. So let me just do it for you a little bit. A probability that A hits the target is 1 by 3. So into probability B does not hit, that is 3 by 4, right? Into probability that C does not hit, it's 4 by 5. Plus you solve this one here, you solve this one here, and you calculate the answer. So I hope everyone understood how I calculated exactly one of them hits the target. Now what is the probability that exactly 2 of them hit the target? Now you must be thinking, all right, so let's go ahead and do that. So exactly 2 of them hits the target. So how are you going to do that? So A hits the target, B hits the target, C doesn't, right? Similarly, A does not hit the target and B hits and C hits. Similarly, A hits, B does not, and C hits. Calculate that, you have your answer, right? So I hope everyone understood what I did here. I just found the number of cases and just added them, right? So this is how you can do this question, right? So let's just move ahead and do the last question of the video. So in this question, Xavier, Yuan, and Zelda each try independently to solve a problem. And if they solve it, the probability of them solving it is 1 by 4, 1 by 2, and 5 by 8 respectively. So let me just remove this and it's redundant. What is the probability that these 2 hit the target and this doesn't? It's very simple, guys. Now I hope watching this video you will be able to easily solve this question, right? This is a very easy question. This hits, probability 1 by 4. This hits, probability 1 by 2. This doesn't. Since the probability is 5 by 8, the probability of not doing is 3 by 8. You calculate that, you have your answer, right? So I hope everyone understood what we did over here. We learned the basics of the probability, right? So keep sticking for more videos. So I'll be posting more videos on the same topic, the probability topic. And thank you for watching the video, and thank you for sharing it, because I know you'll like it and I know you're going to share it on your Facebook, Twitter, whichever way you can, because this is the only currency through which we survive, right? So thank you for watching this video. This is my email address. In case you want to send me an email, you want to send me a feedback, please, I would love to have your feedback. And thank you very much, and see you in next video.